Assalamu alaikum warahmatullah. Dear students, today inshallah we're going to talk about the triangle and its relationship between triangles. So if we talk about triangles, we need to know what the triangle is. Triangle is a polygon, and the polygon means closed sides. So I have two sides there. Once I close these sides by drawing another side, this is gonna make a triangle. So the triangle is a polygon, consists at least of 3 sides. So this size may increase to be 4 sides. For example, if I draw 4 sides like this, it's gonna be quadrilateral. So the quadrilateral is a polygon, has 4 sides. Which is type of quadrilateral? This is called square. So come back again to this triangle. So the triangle, okay, if we talk about the triangle, we need to know the type of this triangle and how to classify the triangles due its sides and angles. Let's talk about these triangles and sides. If we talk about sides, we have 3 types of triangles. First of all, there is an equilateral triangle. Equilateral triangle means triangle has 3 sides equal in measure, equal in length, and the sides of these angles equal in measure, and each of them is 60 degrees. Okay, this angle looking to these sides, and this angle looking to this side, this angle looking to this side. So this side has this vertex and this vertex in this triangle. So the third vertex is there, looking to this side. So this angle opposite to these sides. And because we have 3 sides equal in length, therefore there is 3 angles equal in measure. This is an equilateral triangle. Okay, about the isosceles triangle. Isosceles triangle means a triangle has 2 sides, just 2 sides equal in length, and this side opposite to this angle, and this side opposite to this angle. So both of these angles, which is called base angles, these base angles are equal in measure. Okay, once you get any angle of this isosceles triangle, any angle inside this triangle is 60 degrees, it's gonna be an equilateral triangle. Done? Okay, the third triangle, if we need to know the type of the third triangle, is a scalene triangle. Scalene triangle is a triangle has 3 different sides, and because you have 3 different sides, this is mean you have 3 different angles. We're going to talk about both of these specific triangles. We need to know more about them. Okay, this is the triangles due its sides. If I need to know the type of these triangles due its angles, let's talk about the triangle due its angles. How could I classify these triangles? I have 3 different rules you need to know about them to know the triangle is acute or right or obtuse. Acute or right or obtuse. How could you know the triangle which is draw like this? This is a triangle. How could you know this is an acute angle triangle? Okay, you have 2 ways, using the angles and using the lengths. Okay, the rule which we need to apply using the angles. Any acute angle triangle, the measure of this angle plus this angle supposed to be bigger than this angle. Okay, I made a mistake there. I put the same mark in this angle, which is mean this angle equal to this angle. Done? Okay, if I make an x, a mark like x like this one, so this is not equal to this. Okay, if you get any 2 angles inside this triangle and you add them, so angle 1 and angle 2, this is 1, this is angle 2, this is angle 3. So angle 1 plus angle 2 supposed to be bigger than angle 3. So this is an acute angle triangle. If we talk about the right angle triangle, this is the shape of the right angle triangle. Okay, this square means there is a 90 degree. 90 degrees make this triangle is right angle triangle. How could you know this is a right angle triangle? Using the same rule, something like this. Okay, if I suppose this is 1, this is angle 2, and this is angle 3. So if I take angle 1 and add it to angle 2, and I found it's equal to angle 3, so this is a right angle triangle. So 45 plus 45, for example, is 90. The third angle is 90. So this is a right angle triangle. About the obtuse angle triangle, something like this. So this is an obtuse angle triangle. The obtuse angle triangle is an angle more than 90 less than 180 degree. This is angle 1, this is angle 2. If I add angle 1 and angle 2 together and found their sum smaller than angle 3, so this is gonna be an obtuse angle triangle. This is the way to know the type of this triangle due its angle using the rules like this, using its angles. I can use the side length also to get the type of this triangle. So if I asked you what's the type of triangle due its angle using length of sides, for example, this is a triangle, length 1, length 2, length 3. This is another triangle. I know you know it, you're gonna tell me this is right angle triangle, length 1, length 2, length 3. This is another triangle, third angle on obtuse 1, okay, length 1, length 2, length 3. Okay, let's play with these. Okay, the first one, it's supposed to be an acute angle. How could I know? Okay, take the smaller sides. For example, length 1 and length 2 smaller than length 3. So if I add length 1 power 2, if I square the first length and add it to the square of the second length and found it also bigger than the square of the third length, so this is going to be an acute angle triangle. Okay, if I take this side, the square of the first and the square of the smaller sides, it's going to be equal the length of the third side power 2, so it's going to be an right angled triangle. If I take the square of the first and add it to the square of the second and found it smaller than, like this one, smaller than the third square of the third side, this is gonna be an obtuse angle. Obtuse angle triangle. So today inshallah we talk about how to classify the triangle due its sides and due its angle. Due its sides, we get the type of this using these rules, and the type of this triangle using the measure of angles. Okay. Also, we need to talk more about the properties of the equilateral and isosceles triangle. Okay, about the equilateral triangle, we said before, 3 sides are equal in length. So there is 3 angles congruent and each angle is 60 degrees. The isosceles triangle, 2 sides equal in length, so 2 base angles equal in measure. And once you found any angle inside this isosceles triangle is 60, it's gonna be or become an equilateral triangle. Scale in triangle, 3 sides different. Okay, about the angles, we get the rules how to classify the triangle due its angles. Okay, we need to talk more about the triangles. Okay, done. If I draw a triangle like this or any polygon like this, if you take this side or this side or this side and you extend it, but you need to extend it clockwise or anti-clockwise. Okay, if you extend it clockwise, so it's gonna be like this. Okay, by extending these sides, we're gonna make there something called exterior angle. This exterior angle, I have a properties of inside this rule. The exterior angle, this one, equals sum of non-adjacent. Non-adjacent, this is adjacent. Adjacent means beside it. Non-adjacent, so you're talking about this and these angles. So this exterior angle equals the sum of this angle and this angle. For example, this angle is 30, or make it 70 degrees. and this angle is 30 degrees. So 70 plus 30 gonna make 100. 100 is the measure of this one, exterior angle. Okay, what if I draw this triangle again and I extended these sides not clockwise, anti-clockwise, like this one? So I'm gonna extend this like this, like this, like this. So this is the exterior angle I found. This exterior angle, this adjacent of it. Okay, so the non-adjacent gonna be this and this. So the measure of this plus the measure of this gonna get the measure of these angles. Okay, but if I divide this polygon like this to make a construction, okay, so I made their triangle and there is another triangle. So because this is an exterior angle, equal measure of this angle plus this angle. So I can apply this rule just in the triangles. But you need to know something. The measure of this exterior and this exterior and this exterior is supposed to be the sum equal 360 degree, and this is a constant. And I know the sum of this and this and this and this also at any polygon, the sum of any exterior angles at any polygons gonna be 360 degrees. Okay, if I take these sides, I broke it like this, not extended. So I can call this is not exterior angles. This is not exterior angles. Take care, because this is not extended from this side. The extension gonna be like this. So this is broken side. So I need to know how to get the measure of this one also to get the length of the exterior angle. Okay, there is another thing we need to talk. Any triangle, whatever, acute or right or obtuse, the sum of this angle plus this angle plus this angle is constant. The sum gonna be 180 degrees, the sum of interior angles. And if you cut this and this and this to put them beside each other, so this is angle 1, 2, 3. I'm gonna make it also there 1, 2, 3. So this plus this plus this is gonna be 180 degree straight angles. Okay, if you open your book page 176, you're gonna find some questions on classifying triangle due its sides and angle. For example, number 24, he asks us what's the type of the triangle due its sides and angle. He draws something triangle like this. He made this equal to this. He wrote this 59 degree, this 59 degree, and this is gonna be 62 degree. And by looking to this triangle, I found this is side equal to side. He marked the same mark on this side and this side. So this equal to this, and I found these base angles are equal. So this is an isosceles triangle due its sides. By looking to the angles, this is an acute, acute, acute. So once you get 3 acute angles, so this type gonna be acute angle triangle, isosceles triangle. So at least you need to know at least there is 2 acute angles inside this triangle. And if you found the third angle is acute, it's gonna be acute. The third angle is right, it's gonna be right. The third angle is obtuse, it's gonna be obtuse. For example, in number 27, he draws something like this. He made 1 line, 2 more, 3 lines. He made this 90 degree. So because this not equal to this, not equal to this, so this is a scaling triangle. And this is a right angle triangle, because this is the sign of the 90 degree. And if you look to the other 2 angles, acute and acute, so any triangle, at least there is 2 acute angles. The third is acute, gonna be acute. The third is right, gonna be right angle triangle. The third is obtuse, gonna be obtuse angle triangle. Okay, this is a type of question in page 176. If we jump on page 182, okay, there is also an exercise about talking about the exterior angles. The exterior angle, how to use this rule to find measure of angles. For example, number 12. Let's go to number 12. Number 12 asks us, what's the type of angle 2? Sorry, what's the measure of angle 2? So he draw a triangle like this. and he took this side and he extended. He made an angle there too. This angle is 98 degrees. This angle is 50 degrees. Okay, this is not adjacent to this. This is also not adjacent to this. So this plus this is gonna get this. So angle 2 equal 50 plus 98 to get the result of this third angle. Also number 13, for example. No, let's use number 14. Number 14, there is another type. You're gonna play with this rule. This is an angle. You draw something like this, and you took this side and extended. They give you the measure of the exterior 145 degrees, and the measure of this is gonna be 102. He asked you to get the measure of this, which is called 2. So this is this angle plus this angle equal the exterior. So this minus this gonna work out this. So angle 2 there gonna work out angle 2 by subtracting 102 from 145 minus 102 to get the measure of the angle 2. Okay, if we use the sum of measures of the interior angles, you know, as I told you before, any triangle has 3 angles. The sum of these angles is 180, and this is a constant value of any inside of the measure of this angle inside this triangle. For example, he draw a question number 6 on the same page. He draw a triangle like this. He gave me this angle is 1. He gave me this 78. He gave me this 31 degrees. So I want you get the measure of this angle. Okay, measure of angle 1. If you want to work out measure of angle 1, I know this plus this plus this supposed to be 180. So 180, I'm gonna take off this angle and this angle. So 180 minus 78 minus 31 to work out the measure of angle 1. Okay, question number 8, for example, he give me a right angle triangle like this. Make this 90 degree. This is angle 1. Here we need you to work out angle 1. This is 38. Okay, you need to know the 180 equal to 90 degree, 90 and 90, and because each 90 is 245, so 180 is 2 90s, and 180 at the same time 445. So 180 divided 2 gonna be 90, divided 4 gonna be 45. Okay, so this plus this plus this is 180, and because this is a 90 degree, so from 180 I take off 90 degrees, so the rest is gonna be 90 degree. The rest is this and this. So you have 2 ways to get the measure of angle 1. Measure of angle 1 is 90 minus the second angle, or we're gonna use angle 1, which is 180 minus the sum of both of these angles, which is 90 plus 38 degrees. This is the way to get the measure of the unknown angle using the sum of measures of interior angles. Okay, let's try to use the algebra and geometry. Also, all of them is math in the end, so you don't need to separate them. Okay, for example, he give me in question number 18, he draw a triangle like this. Okay, he give me the measure of this 2x, and this is x, and this is 2x plus 15. I need to know the measure of each angle, So how could you know the measure of each angle? I told you before, by creating equation, because these equations help me to solve any problem. But this problem has how many unknown? Okay, let's create an equation in one unknown, because I see there is x, the same number already exists in these angles. So let's create an equation, and I know this plus this plus this is 180. So if I add them to be x plus 2x plus 2x plus 15 supposed to be 180 degrees. Okay, let's add them. This is alike terms except 15 doesn't include x, so this is not alike to like these terms. Okay, x and 2x, apple plus 2 apples, 3 apples, and there is 2 another apples. 3 and 2 gonna be 5x, so 5x plus 15 gonna be 180. So this is equation because this is term equal to term and there is unknown. So how could you get the unknown? By using the inverse. This is okay. There is 15 already added to this term. I need to read the expression. There is 15 added to this. So the inverse of addition is subtraction. So I need to subtract first of all 15 from both sides. So there 5x, looking in the top and right there, equal 180 minus 15, because there is a section without calculator, we need to calculate it. Okay, I'm gonna use this 80 to subtract 10, gonna be 70. 70 subtract 5, gonna be 65, and there is 100, you have 165. Divided 5, because the relation between both of them is multiplying. So this gonna cancel this. X equal, oh, how could you divide it without using the calculator? Because you may found this question in your section. Okay, I'm gonna separate it. 1 divide 5, I can't, so I'm gonna make it 16 divided 5. 16 divided 5, 16 is bigger. 16 is bigger, so I can divide it, but 16 not exist in table 5. So use your finger and decrease it 1. 16 I can't, make it 15. 15 divided 5 is 3, and this one gonna put it there to be 15. 15 divided 5 is 3. So this is the value of x. So this is gonna be 33. And supposed to be accurate, not obvious, so I made a mistake there. This is 2 multiply 33, which is going to be 66 degree. This is going to be 2 multiply 33, which is 66. 66 plus 15. So this is going to be 66 plus 15, which is going to be 70, 81. Okay, you need to check your answer. So let's check our answer by adding 81 plus 66 plus 33, you're supposed to get 180 degrees, so I have the right answer. Okay, I need you, Bismillah, to solve many problems in these pages. And let's try to use another exercise in exercise 4.3. Exercise 4.3. Okay, so I'm gonna use this empty area to use algebra and geometry also. Okay. Page 188, there is a question number 7. Find the value of x. Tell what theorems. Okay, I don't need the theorems you used, but he wanted me find the measure of angle x. Number 7. Number 7, he drew a triangle like this. He made this equal to this. He wrote there 55, and there is x, and he wanted me get the value of x. Okay, to get the value of x, by looking to this triangle, I found this is 2 legs equal, so I know this opposite to this side and this angle opposite to this side, so this supposed to be equal to this, so x gonna be 55 degrees. This is a rule I use. Okay, let's try another one. For example, number 10, question number 10. Okay, number 10, he draw a triangle like this. He made this equal to this. He wrote there 11, and this one he wrote x plus 4, and he asked me to get the measure of angle x. Okay, so I need to create an equation. So by looking to this, we found this equal to this, and because this side opposite to this angle and this side opposite to this angle, so I'm gonna say this side equal to this side. So I create equation already by saying this equal to this. So we're gonna say x plus 4 supposed to be equal 11. So what's happened to x there in this equation, specific in this expression? There is 4 added to x, added, so subtract 4, subtract 4. This is gonna cancel this, the remainder gonna be x, there is equal 11 minus 4, which is gonna be 7. 7 plus 4 is 11. This side equal to this side, so I'm right. Okay, this is a type. We can use this algebra to solve problems in geometry. Let's create another equations. For example, question number 17, page 189. Question number 17. He draws something like this. He draw a triangle. I don't know, it's supposed to be obtuse. Okay, he wrote there x. He wrote this equal to this. He gave me the measure of this angle, which is 30 degrees. This is A, this is B, this is C. I want to get the value of x. How could I get the value of x? Give me this equal to this. So this angle is supposed to be equal to this angle, right? Okay, this is 30, so this is going to be 30 also. This is the property already exists in the isosceles triangle. And also I have a theorem tell me this and this and this angle, the sum of this measured interior angle supposed to be 180. So 180, I'm going to take off 30 and 30. So 180 minus 30 minus 30, I'm going to get the value of the third one. There is 60. 180 minus 60 going to be 120 degrees. So this is 120, and there is a 60, 180. The sum of interior angle is 180, so I'm right. Okay, let's try question number 25. 25, he draws a triangle like this. He gave me this equal to this equal to this. How could you know the same mark? The same mark. He gave me this 8y minus 10. He gave me this 4y plus 2. Note that he gave me the same value, the same variable, sorry, y. So this is an equilateral triangle. So this equal this. So I need to get the value of y. I'm gonna say this equal to this. This is a property already exists in the equilateral triangle. So let's create an equation to say 4y plus 2 equal 8y minus 10. Okay, so how could you solve this equation? So I need to collect the like terms together. So tell me, mister, I need to put this there or translate this term there and send this term there. So I prefer to send this 4y to the other side and take 10 to this side. Okay, I'm gonna use my eye because in the end they are equal. So once I send this there, this is positive gonna move by negative sign. Who's gonna receive it? 8y. So write 8y first. This is gonna be there minus 4y. There is equal. I have to put it as it. Okay, I send 4y there. I need to take negative 10 there. Negative 10 gonna go there. Positive 10. Who's gonna receive it? 2. Positive 10. So 8y minus 4y. Excellent. Equal 2 plus, yep, which is going to be 12. The operation between this and this is multiplied, the inverse over 4 over 4. So y going to be 3. Okay, all I need you to solve this page 189. So this is homework. I need you to complete it, inshallah, to complete our video next time. Bismillah. Thank you.